Dear students, I am KAPIL SHARMA, lecturer in Polytechnic College Ajmer. Today we are going to discuss about the electromagnetic flow meter. This flow meter is very useful for measurement of flow in industries. It is based on the principle of Faraday's law. As shown, this flow meter is having two electromagnets on both the sides of the pipe, and the liquid flow behaves like a conductor, and the two sensors of measuring voltage are to be placed at the perpendicular to the conductor. According to the Faraday's law, we know that the EMF induced in any conductor which is moving in the flux with rate of change of flux, it produces a EMF. So this EMF can be measured by these two sensors, and this EMF can be represents the measurement of flow as shown in this derivation, that E is equals to N d phi by dt. N is the number of conductors. Here the number of conductors are showing the fluid, and E is directly proportional to the differentiation of B into A. B is magnetic flux density and A is the area divided by time, and this is again separated, and this gives the E is directly proportional to the N. dB means flux density, D is the diameter, and V is the velocity. So the velocity of the fluid can directly proportional to the induced EMF across the pipe. So this is in this electromagnetic flow meter, the flow of the fluid works as a conductor, and sometimes the ionization effect is generated because of the permanent magnet used across the pipes. To avoid this ionization effect, we use electromagnet for avoiding the ionization effect, and the polarity of the magnet is continuously changing. And in this flow meter, the pipeline should be insulated, or it may be rubber lined steel tube is used, or electrically insulated pipe surface is used. And the one condition is also required, that the flow liquid is also in conducting nature, means it should behave like a conductor. Then only it can be used for measurement of flow by using the electromagnetic flow meter. Our next topic is ultrasonic flow meters. Number first is transient type flow meter, and second is Doppler type flow meter. Doppler type flow meter we will discuss later on. Number first is transient type flow meter. It is the flow meter having a transmitter and receiver. Both transmitter and receiver works as transmitter as well as receiver. These are to be kept at the outside of the pipe, and the sound waves can be generated by the transmitter, and the sound waves is received by the receiver. According to the principle of this transient flow meter, we know that velocity is equals to distance by time, and the time can be represented by distance upon velocity. So the forward path, for if one transmitter transmits a sound wave and another is received a sound wave, then if it is in it supports the line, if the velocity of the fluid supports the velocity of the sound wave, then the time will be forward time is equals to length is L upon velocity C plus, C is the velocity of sound plus velocity of the V is the velocity of the fluid, V cos phi. V cos phi is the factor of the vector factor of the sound wave. Okay. Then if one transmitter again replaces by receiver, and the transmitting waves is sent from the upward side and received by the lower side, then it is against the flow, because the flow is from left to right. Then this time TB is L upon C minus V cos phi. In this way, by adding and subtracting, we will get the velocity of the average velocity of the fluid is directly proportional to the difference of time. Means backward time is more than the forward time. Forward time means which is in flow with the fluid. So the average velocity is directly measured with the help of these two sensors. And first we will calculate the time, and then average velocity is to be calibrated in terms of time. This is the working principle of transient type flow meter. This is all about for today. For Doppler's type ultrasonic flow detector, we will discuss on later on.